Subscribe to Ancient Hands before we begin, would you? Because what you are about to learn is not recycled camping advice or modern marketing hype. During World War II, engineers developed a fabric so strong, lightweight and waterproof that it outperformed modern tarps and synthetic rain gear under extreme conditions. Soldiers relied on it in jungles, deserts and frozen landscapes, and, well, some original pieces still repel water decades later. Understanding this fabric reveals forgotten engineering principles that remain relevant to survivalist historians and anyone who values durability over disposable gear. Why World War II forced engineers to rethink how fabric could withstand everything. During the war, soldiers faced conditions that civilian equipment could never anticipate. Constant rain, snow, mud and humidity destroyed traditional canvas and coated materials. Rubberized fabrics cracked in the cold, while waxed cloth wore through within days. Military engineers needed a material that could withstand folding, abrasion, chemical exposure and prolonged immersion without failing. The solution was not heavier fabric or thicker coatings, but a new approach that combined weaving, fibre selection and chemical treatment. They had to make a fabric that could move with the soldier, resist the elements and stay functional over months of rigorous use. So, what really set this remarkable World War II fabric apart from anything that came before or after it? Well, let's take a closer look. The real secret, you see, was in the fibres and the treatment. Engineers relied on tightly woven natural fibres like linen and cotton, but here's the clever bit. They treated them with a combination of oils, metallic salts and polymerizing agents that actually penetrated the fibres, instead of just sitting on the surface. When the fabric got wet, the fibres would swell a little, closing up those tiny gaps in the weave. Water simply couldn't get through, and yet the fabric stayed flexible, breathable, and, well, surprisingly lightweight. Unlike modern plastics, which often crack under stress, this treated fabric absorbed impacts, resisted tearing, and just kept on shedding water, even after years of folding and rough use. So, why did this fabric outperform modern tarps in real-world conditions? Let's find out. Plastic and synthetic tarps rely on a surface barrier to block water. This makes them effective for short-term use, but, you know, they tend to fail under prolonged exposure, high winds, or even just folding. Condensation trapped under these tarps often soaks gear, despite the waterproof shell. The World War II fabric worked differently. Its water resistance was structural, meaning that even when folded, stretched or punctured, the fibres themselves repelled moisture. Soldiers could use it as shelter halves, ponchos and pack covers, and, well, the fabric would still function after repeated use. How soldiers applied the fabric in the field and why it mattered. Shelter halves were the most common application. Two pieces could be buttoned together to form a tent, laid over gear as a cover, or worn as a makeshift poncho. The versatility of the fabric meant that a single item could serve multiple functions, reducing load and conserving resources. In practice, this allowed soldiers to remain dry in extreme weather without carrying extra tarps or waterproof gear. For modern survivalists, this principle can be applied by using durable treated cloth for multipurpose shelter, equipment covers or protective clothing, minimizing dependence on specialized gear. Now, it's actually quite fascinating. Despite all our technological advances, modern engineers still struggle to replicate the remarkable durability of this fabric. You see, the combination of fibre selection, weave density, and chemical penetration actually created a level of durability that, honestly, modern materials science finds rather difficult to duplicate. Synthetics, for example, often fail because they simply can't mimic the responsive swelling of natural fibres. Tarps tend to fail right at stress points, and while modern fabrics may repel water at first, they tend to degrade under repeated flexing. The secret to that World War II fabric's longevity was embedding the water resistance into the fibres themselves, rather than just relying on coatings. This principle, well, it remains underutilized in most modern outdoor gear, which often ends up prioritizing weight or convenience over true real-world durability. So let's talk about how you, as a modern user, can actually apply this knowledge in a practical way. First, select tightly woven natural fabrics such as linen, cotton duck or canvas. Next, treat them with a deep penetrating oil or resin solution, ensuring the fibres themselves absorb the protective agent rather than simply coating the surface. Allow the fabric to cure fully, which can take several days depending on the treatment. Once cured, the fabric can be used in multiple ways: as a tarp, shelter half, pack cover or clothing reinforcement. The goal here is to replicate the structural water resistance the World War II fabric achieved, emphasizing longevity over temporary convenience. Now, why does this fabric represent a lost lesson in engineering and survival? Well, it's really about understanding the ingenuity and practical thinking that went into its creation. Modern gear often sacrifices durability for lightweight materials, convenience, or mass production efficiency. The World War II fabric demonstrates that a well-designed, treated natural material can outperform modern synthetics in harsh conditions. It teaches that real-world performance relies not on marketing claims, but on thoughtful design, careful treatment, and understanding material behavior. Historical engineering like this continues to offer lessons that remain practical today, especially for those interested in survival, long-term preparedness, or historical recreation. So, subscribe to Ancient Hands if you value historically proven solutions that outperform modern shortcuts, and share this episode with fellow history enthusiasts and survivalists. The lessons embedded in this World War II fabric are more than a curiosity. They are a blueprint for building gear that lasts, protects and performs under conditions that modern materials often fail to endure.